In this video, we are going to continue the fluid flow over the cylinder. So I'm just opening the setup. I have already done the geometry and the meshing process. We will double precision and 16 and then start. So this is a continuation video of the fluid flow over the cylinder. As I already done the geometry and the meshing process. This is a fluent setup. What we are going to do here is boundary conditions, applying all those boundary conditions and the models. So the fluent is opening right now. So connect with the previous video so that you can able to understand. So here it is the inlet and outlet, you can able to see in blue and red color lines respectively. So in this setup we are going to do analysis, which is a fluid flow over this cylinder which is present inside. So go to general. So in that general you can able to see steady transient and that Q transient. So this is a basic condition because with respect to time it is changing. And then go to viscous, give laminar and then OK. First we'll focus on the laminar flow and then we will change the Reynolds number based on the velocity by changing the velocity. So first then we will move on to the materials. Under materials we can able to see the air. The density we will give us 1 by changing 1.2 into 1. So other than that you don't need to change anything. So go to inlet. In that inlet we have to give the boundary conditions. So give the velocity which is flowing over the cylinder. So air which is flowing over the cylinder, you just give 0.02 meter per second, apply, close. So this is basically based on the Reynolds number. So you need to no need to give anything in the boundary conditions. So under solutions you can able to see the initialization. Go to hybrid initialization, initialize. Once you give initialize, the initialize has been hybrid initialization is done. You can able to see in the middle. So next you go to the report definition. Then you need to create a surface report because it's a structural way to find out the fluid flow over the cylinder. So you can able to see the force. You need to find out the drag force and the lift force from this fluid flows over the cylinder. So I will type drag coefficient by clicking a drag. You need to type a drag coefficient. So in the report output type also you can able to see. Click the cylinder, then compute and then OK. So you need to give the lift as well. So go to edit. So we need to give, you need to create it own. We need to create one new thing. So I will just create a new force drag coefficient and then drag force. First I gave drag coefficient. So now I am giving the drag force. So compute into console create output parameter. Compute OK. So again you need to give, so you can able to see the drag force and the drag coefficient. So these are the values you can able to see. So here also I am just giving parameters. No need to change anything. In the report definitions, new surface report force lift. So here we have to give lift force as well as the lift coefficient over here. So already we gave drag force as well as a drag coefficient. So here we are giving a lift force and the lift coefficient. Compute and then OK. Print to console. Click OK. So again I am giving, as I already told, lift force in the cylinder. So that is a very important thing. You need to give that cylinder, not in the wall. So based on this you can able to get a result after giving a run calculation. So we have given all the report definitions, and for plot we need to give separately, and this is a plot we have assigned over here. So from this also we can able to get the result. So under monitors, so you need to change, no need to change anything. So these are the basic parameters you need to check before giving a run calculation, whether we gave a right or wrong for all the parameters. So once we verified, once we cross check, we'll go for the further one. So under animations, you can able to see mesh, contours, vectors, path lines, sweep surface, everything is there. So I'm just cross checking what you have done, the methods and the calculation activities. You have auto save, and then for every time steps how it is saved. So this also we have. So it is 1 0, so just to give 1 for every time step the file will be saved. This is the basic thing. If you want to give, you can give, but if your computer does not have that much storage, or your laptop does not have that much storage, you don't need to give. But under solution animations, you can able to see the residuals, able to force, plot, lift, drag coefficient, and everything is there. In that you need to give. If you want counter you can give, but I'm just giving the counter. I want counter, so I'm just giving, selecting the counter by clicking a new object. Under counters of whatever you want, I'm just clicking the velocity. So in the velocity you can able to see the structure, the counter before giving the run. So click on counter 1 and then OK. So this is a velocity counter. You can able to see in the structure. So velocity magnitude, which is an exponential form. So again, if you want to give anything further, you can give. So here I'm giving the number of time steps. This is a transient flow. I'm just giving 100 and time step as 0.01. We will see what is the result. Is varying based on the time step, number of time step, and the time step size. So you can able to see the plot. You can able to see the counters of velocity, magnitude, as well as drag coefficient, drag force coefficient, drag coefficient, lift coefficient, and then lift force as well as the drag force. So you can able to see everything in the graph. So it just calculating. So based on this results, we can able to find out the way how the fluid flow is changing with respect to time. So we'll wait for some time up to the end of the calculation. We have given 100 time steps, but the time steps is very less. 0.01 is a very less time step. You can get a accurate plot. So that is the reason we are reducing the time step. If we give 1 as a time step, the calculation will be very fast and compared to this time step. So we will wait for some time. Almost 70% has been done. So after this calculation, you can able to find out the drag force. So in this velocity magnitude, I have not selected everything, so that's why the velocity magnitude has not changed. So that is the reason you can able to see the velocity contour. It does not change any color. So it is because I have not selected all the things while giving the contour. That is the reason it is not changing. If you are giving, you can just select all those things. I forgot to give. Sorry for this issue. So just give, select all all the items, all the things. So calculation has been done. So this is a scale residual. You can able to see. It's a drag coefficient plot. Series with respect to the flow time, and then drag force in Newton. This is seconds. So drag coefficient, and then lift coefficient, and then lift force with respect to time, Newton. So this is a counter. So as I already told, this counter is not varying because I have not selected the things which is related to the counter. So while we are giving the counter, we need to select everything. So this is a counter. You can able to see it is an exponential. It is an exponential. So if you want to change the number of time steps, you can change it whatever you want. So for more information, subscribe, like, and share this video. So this video is useful for you for learning more computational fluid dynamics related informational videos. So we will do more analysis based